in the space of science and gigantic, privileged insights the subject of what existed ahead of time to the huge impact, has blended conversations and intrigued characters for quite a while. This Goliath request doesn't just test how we could disentangle the universe, it challenges the genuine farthest imperatives of human data. Imagine standing at the edge of existence, examining the gigantic shadowing and taking into account what lay there. Before our universe was imagined, the event of the Big Bang marked the beginning of history, space, and what we know. In any event, there was a moment sooner in advance. This may have eventually been a condition of nothingness, a calm before the bombastic gathering started. And assuming this is legitimate, was it, or perhaps there was something significantly more upsetting that existed before time itself? As we skip further into this request, science takes us on a journey past the universe's beginning stage into thoughts that challenge our mindfulness. Physicist Brian Cox, known for his commitment to the miracles of the universe, suggests that something shocking might have existed before the Big Bang. He moves us to rethink our thinking of the genuine world and existence. In this evaluation, we'll dismantle the science, the speculation, and the astounding insider secrets that might sort out what existed before. All that we'll explore contemplations like godly improvement, quantum changes, dark energy, and even multiverses. The reaction we've covered might just stifle you, but they could also open new understandings of our circumstance in the universe. Plan to jump deep into a world beyond imagination and science, where the dark still wins around the shadows, leaving scientists shocked and sometimes even steamed. We ought to examine what existed before the Big Bang and why these theories challenge all that we expected we knew to appreciate what could have existed already. The Big Bang. We first need to look at what the Big Bang in fact was. The Big Bang, as scientists describe it, refers to the event when the universe became extraordinarily hot and thick, expanding rapidly to set off the formation of all matter, energy, and boundless forces. When we look toward the night sky, we see evidence of this hot beginning, with systems spreading out from a starting point. At any rate, for what reason did this occur, or was there a time before this thick hot start? As shown by the theory of cosmic inflation, there was without a doubt a before, and it was off by far to void or quiet. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, vacant, and free, fundamentally like an epic vacuum. In any event, the vacuum wasn't completely unfilled. It contained a monstrous amount of energy that controlled the rapid extension of space itself. This expansion, called inflation, happened so rapidly that it generally settled the reason for all that would continue in a piece of an ongoing space. It expanded at unbelievable rates until the expansion slowed down and the energy changed into issue particles and the forces we consider the Big Bang. But what was the nature of this energy? Why did it from nowhere foster the universe? And for what reason did it stop? Scientists believe that this boundless expansion created patches of the universe, each encountering its own Big Bang. Imagine a fabric widening ceaselessly with minuscule air bubbles forming. Each bubble represents a universe, including our own. This thought, called the inflationary multiverse, suggests that there are potentially unfathomable Big Bangs and a boundless number of universes. Our own is only one of many. This tremendous, mind-bending reality challenges how we could decipher the very universe itself and leaves us with the question, what else is out there? The concept of nothingness before the Big Bang is theoretical, not real at any rate. According to our current understanding, even if you kill all energy particles and radiation from the universe, it would still not be genuinely void. Our universe is topped off with dark matter. Dark energy quantum fields, and various forces that weave a certain woven masterpiece of something indeed even in its most unfilled structure, regardless of weather. We imagine stripping away these powers, leaving a dead space. The universe would still make new kinds of energy. This only reality is baffling to scientists, as it suggests that genuine nothingness may be unfathomable within our vast understanding. Space itself has properties, rules, and constants that keep it from being completely unfilled. Imagine creating a region with literally nothing in it, no particles, no radiation, and negative energy except for quantum fields and huge constants. These would still exist, suggesting that this nothingness has properties. For instance, there's a concept called spin energy, which represents the most unimaginable energy state of quantum fields. In this state, particles can still appear and dissipate, creating a dreadful resonance of improvement even in what should be empty space. This challenges what we would call a true void and suggests that, yes, even before the Big Bang there was something. Analysts are still beginning to appreciate this, potentially one of the most astonishing speculations in current cosmology is the chance of undying development. If inflation could create our universe, it's possible it could continue perpetually. Brian Cox describes an extraordinarily colossal, inflationary multiverse where universes are unimaginably created and expand. Imagine each Big Bang as a spark, lighting another universe while inflation happens in different regions, creating innumerable other universes. This cycle could in theory happen forever. This idea of colossal universes siring others leads to a charming thought of a fractal universe where each new universe may in fact create its own Big Bang. Every universe exists as an alternate independent space unaffected by the others. Considering the rapid development of space for researchers, this hypothesis is both exhilarating and upsetting, as it suggests an interminable multiverse with no clear beginning or end. Imagine our universe being just a tiny bit in a beast's boundless plan, constantly developing and always making new universes. And what if that's the true nature of reality? There is no before or later, but rather an undying pattern of universes forming. How we might interpret nothingness changes when we consider quantum field theory. As demonstrated by this theory, the universe isn't just a mix of matter floating in space. Perhaps it's a complicated connection of energy fields that fill the universe, interacting to make all that we notice. These fields are like intangible seas with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and evaporate in these fields, promptly obtaining energy before returning it. This characteristic leads to virtual particles, substances that immediately exist and then vanish, leaving only a faint memory of their presence. The thought of virtual particles challenges the plausibility of a true void. Imagine an unfilled universe where all matter, radiation, and energy are removed. Would you have in fact nothing? According to quantum field theory, you wouldn't. Even in a vacuum, fields would stay dynamic, sometimes making transient particles. This constant development in what should be nothing suggests that the universe doesn't abide by our concept of emptiness. The fields and forces endure, filling the universe with private energy that prevents absolute nothingness. Understanding raises a fascinating question. If fields create particles and particles create matter, might the actual universe have arisen from this nothingness filled with quantum fields? Dark energy is an odd force that currently drives the accelerated expansion of our universe. However, did dark energy exist before the Big Bang? According to certain perspectives, the fact that dark energy exists today is an after effect of an energy field from before our universe's Development, the properties of dark energy seem to suggest a giant secret for force that might have existed in some form before the Big Bang. Some speculations propose that dark energy in a much stronger state could have controlled the inflationary stage, causing rapid expansion. The presence of dark energy suggests that whether our universe were emptied of all matter and radiation, this force would continue to develop the surface of spacetime. This thought prompts an upsetting request. If dark energy was present before the Big Bang, could it have eventually formed the conditions that led to the birth of our universe? Could dark energy be the quiet architect of inflation, or even the true beginning of our universe? As we investigate this possibility, we face the potential of dark energy not just as a force shaping our universe, but as a key that could unlock the secrets of the multiverse itself. Another theory is that cyclic cosmology offers an alternative to the Big Bang as a definitive beginning. This theory suggests that the universe goes through immense cycles of birth, death, and renewal. In this model, the Big Bang is not a one-time event, but perhaps part of an undying cycle where universes develop separate and then recover in another cycle. This theory suggests that our universe could have been restored from the remnants of a past universe. The process of compression and expansion in a cyclic pattern would mean that there was never a true beginning, but rather an eternal series of universes emerging, creating, and renewing themselves over and over. Cyclic cosmology raises profound questions. No time like the present, as it suggests that time itself might repeat rather than proceed. If this theory is correct, it could mean that what existed before the Big Bang was simply another form of the universe, one that fell solely to give birth to our current universe. For scientists, this theory offers a rich answer to the question of extreme origins, proposing that there is no clear beginning. The universe has always existed in some form, transcending our thoughts of time and existence. Gravitational waves are another interesting idea that could shed light on what existed before the Big Bang. These waves, discovered in 2015, are swells in space-time caused by incredibly massive objects such as black holes or colliding neutron stars. These waves can travel long distances, carrying information about the events that created them. Could gravitational waves provide information about the birth of the universe? A few physicists propose that gravitational waves coming from the time before the Big Bang may provide insight into the state of the universe before inflation started. Gravitational waves from the early universe might leave clues that could help understand whether the Big Bang was truly the beginning or whether there were cosmic events before that we don't yet comprehend. These waves could be traces left behind by events beyond our usual knowledge. Their presence could also hint at a grander structure beyond the one we are familiar with. These faint signals might unlock pieces of knowledge that could change our worldview, just as we discovered the Big Bang start. What if they show the remnants of a past universe or an event that happened before the Big Bang? As scientists continue to research the deep reaches of space, the question remains what existed before the Big Bang, with current theories pointing toward quantum mechanics, multiverses, and cosmic inflation. It seems we are closer than ever to unveiling the deep mysteries of the universe's origins. While the complete answer remains elusive, our understanding of what existed before the Big Bang continues to grow with each discovery. As we explore these theories, we can also contemplate how they might fit together to show the big picture, the true nature of existence itself. But until then, we are left with the mystery driving science and wandering into unknown places far beyond what we have yet known.